All right. Well, greetings, everybody. I think we can get started. Welcome to our climate update 2026 for New Hampshire and New England. I'm Reinmar Seidler. I'm a member of the steering committee of the New Hampshire Network for Environment, Energy, and Climate. And this is the first of our monthly online events looking at various aspects of energy, of environment, energy, and climate. In New Hampshire, and occasionally we look farther afield as well. Tonight we have two exceptional experts with us who are going to update us on some of the recent research on what we know about climate in New Hampshire and in New England and how we know it. I'll introduce our guest speakers in just a moment. But before I do, I want to share a slide myself because we've received some comments or questions about the distinction between natural and anthropogenic or man-made global climate change. So I thought it would be worthwhile to just give a small glimpse of the global context. So if I can move my slide forward, what we are looking at here is 800,000 years of ice core data showing variations, changes in carbon dioxide content of the atmosphere. These are ice cores from Antarctica primarily, also from Greenland. Greenland doesn't go back as far because the glaciers aren't as thick. But from this, we can extract little tiny bubbles of air that have the chemical content of the atmosphere when the ice was formed. So we can go back even farther than 800,000 years and get a very, very reliable sense of how much carbon was in the air at different times. So here we see this jagged and at first glance random looking line going up and down and up and down and up and down. If we look a little bit more at the pattern, we start to see that these low points happen about every 100,000 years. It's actually somewhat regular. And those are the ice ages. There are 8 of them in the graph that you see before you. So it's 800,000 years and about one every 100,000 years. This is the last one, which ended about 20,000 years ago. Since that time, the temperature has risen quite a bit. This brings us to the present, and we see a sharp, actually vertical line of carbon dioxide. And following that, with the modern instrumental data since 1958, we have very regular, very consistent instrumental data about carbon dioxide content of the atmosphere, and it's going up very rapidly. So this is the distinction that I want to make between natural climate change, which is always happening, but at a very, very, very slow rate. This vertical line only is vertical because it's so compressed in time. 800,000 years is literally an unimaginably long length of time for the human mind can't even grasp how long that is, although it's not really very long in terms of the whole planetary or geological timescale. But what's happened in the last 200 years is all compressed into this vertical line, and it's very radical, the change in carbon dioxide content that's happened. So that's the big context. And from that, we are going to move into talking about the regional changes that are happening just very recently. So let me introduce first Dr. Mary Stampone, who's associate professor of geography at University of New Hampshire, teaches and researches on weather and climate and natural hazards. She's also state climatologist officially for New Hampshire. And in that role, she provides citizens and educators and government agencies with weather and climate information for environmental management, for adaptive programs of various kinds. And she actually participated in the production of a coastal flood risk science report update, which was supposed to be published earlier this year, but is probably going to come out in the next 2 days, something like that. So this week it's coming out. And that's for the New Hampshire Department of Environmental Services. And that will be very interesting to see updates on what we know about sea level rise in New Hampshire. He will be our second speaker. Our first speaker is Dr. Stephen Young, who's professor emeritus and former chair, Department of Geography and Sustainability at Salem State University in Massachusetts. And his research involves using remote sensing, which is satellite data basically, to analyze climate change patterns and deforestation patterns. Dr. Young specializes in northeastern USA, which is us, and China as well. And he, as it happens, not coincidentally, just came out literally a month ago in December of 2025 with his most recent article in the journal Climate, which presents his most recent analysis of what's happening here in New England. And so we are very excited to hear from him. And Stephen, go ahead. Oh, you're muted, Dr. Young.
Needs to unmute.
Okay.
There you
Hi,
go.
everybody. Um, and thank you for inviting me to speak this evening. And there we go. Perfect. Okay. Um, I'm going to talk about New England, what's going on in New England, primarily with temperature and snow cover. And New England actually happens to be one of the faster changing climates in the world, certainly outside of the Arctic. Um, and I will show you why. But first, what I'm going to do tonight is I'm going to give a brief review of the science of climate change. Then I'm going to talk in more detail about temperature and snow cover changes in New England, and then briefly talk about some implications of these changes in our future. And I'm going to start off kind of basic, and I'd like to bring, I'm a teacher, and I like to bring everybody aboard. I don't want to assume everybody knows the very basics, and then we'll get a little bit more detail. So science, right? What is science? And it's a method, it's a way that we understand the world, and it's based on observations. And I highlight that based on observations because to me, that's the most important thing that we do as scientists. We go out, we collect data, and then we learn from that data what's going on. And for atmospheric sciences, we've got a great range of instruments that give us observations about what's going on in our atmosphere, what's going on in our oceans, what's going on in the surface of the Earth. We know as much about the Earth system and how it functions as doctors do about our bodies. And it's amazing what doctors can do now, right? Cut a hole in your knee and do heart surgery. I use three data sets in my research. First, I use this thing called the U.S. Historical Climate Network, which is a set of weather stations across the U.S. that has been highly investigated to make sure that there's a minimum amount of error in the data. And so these are the best weather stations in the United States. Second, I rely on a satellite. And so my specialty is using satellites to study the Earth. And there's a sensor called MODIS that studies the temperature of the surface of the Earth. The weather stations measure what the air temperature is. The satellites measure what the ground is, how warm that is. And the third data set I use is also from the MODIS sensor on the Terra satellite, and it gets snow data. It tells me, is there snow on the ground or not snow on the ground? I'm not interested in how deep the snow is. I want to know if there's snow on the ground or not, and I'll tell you why in a minute. So here are the stations that I use for New England. There's 44 of them. I was looking, trying to get a broad spectrum of New England. And again, these are the best. We've got hundreds of weather sites, but these are the best that go back to even before 1900. On the left is the thermal satellite data that images the every single square inch of New England. Weather stations are point data in different places, but this covers the whole of the area. And then on the right is the snow cover data that tells me if there's snow on the ground or not. And this is the paper that Reinmar mentioned. Decreasing snow cover and increasing temperature are accelerating in New England, USA, with long-term implications. And that's where I am going to talk about tonight. But first, I want to spend a little bit of time on this graph. And this is global temperature. So although I'm talking about New England, let's get a global view. And Reinmar spoke a little bit about this. So along the bottom, we have years going from 2025 all the way back to 1850. On the right-hand side, we measure temperature in degrees Celsius. And we have what we call anomalies. And anomalies are things that vary from the average. And in this case, for this graph, the average is the first 51 years, actually, from 1850 to 1900. And what we do is we take the temperature of each of those years, add them up together, divide by 51, and that gives us the zero base. And every dot, every black dot, is how far that year was either warmer or colder than that, what we call pre-industrial time period from 1850 to 1900. And we can see the blue circle down there is minus 2 degrees Celsius colder than, oops, you know what? I apologize. I just lost my screen and I'm seeing Deborah. Um, can people, I'm going to stop sharing. I'm going to reshare. I apologize about what happened, and I don't really know what happened.
No problem.
Yeah, I can't.
We could see your screen though.
Oh, you could. I just couldn't see it.
We could
Um,
see the
Yeah, it
one
probably got
screen of
lost
the
on your.
temperature variations.
and now exit full screen. Okay. I dearly apologize about this. I have had to teach with Zoom. Okay. All right. Just when I was getting on a roll there. Okay.
Here it comes.
Can everybody see it?
Yep.
Yes.
Great. So I like this black line here. That shows that average of those early 51 years. And the black dot that I have circled there is the last time an annual temperature at the globe was colder than that early period, which is in the 1930s. One thing I want you to notice is the black dots go up and down, up and down, up and down, up and down, because weather is quite variable from year to year. And so one year could be similar or very different from the other year. The red line is an average of those annual dots, and so it smooths it out so we can see more clearly a direction. And finally, these vertical lines tell, in science, we often tell what we don't know as well as what we do know. And those lines say that we're 95% sure that average was somewhere along that vertical black line. And notice as we got to most recent years, our ability to measure the temperature on the globe, we have very little variability. We know pretty accurately what the temperatures are with our modern data sets. Reinmar talked about going back in time with ice cores. This is temperature, not carbon dioxide, that goes back in time and using climate proxies like ice cores or tree rings. And each of these colored lines are a different data set. In science, we often don't rely on one data set. And NH means Northern Hemisphere, not New Hampshire, and some are global. And the red line on the far right is current temperature readings. And you can see on the far upper right, we are really out of the ballpark in what temperature's been like on Earth, at least over the last 1,500 years. So here is New England and the globe, and this is from my data set. And each each dot is a 5 year aggregate. Because every year goes up and down, I average the data into these 5 year averages. And the blue line is global, the gold line is New England. And I want to point out a couple of things. Early on, we see a rise of temperature both globally and New England up towards near the 1950s. Those were natural things that were happening, like increased solar radiation, some greenhouse gas emissions, and then it dropped from the 50s into the 70s. And that is because of air pollution, which blocked a lot of sunlight. But once we cleaned up the air, temperatures have been rising quite quickly. And you can see New England has been rising faster than the global average. And in fact, in the last 5 years, that arrow points to our temperatures actually accelerated. We're not only warming, but over the past 5 years, we have really increased our temperature. And that black line, most of the temperature rise in New England has occurred, and in the globe has occurred since the late 1980s. Even though the data set goes back to 1900, it really is the late 80s when things really started to take off in warming. For New England, the top graph shows the average temperatures between the first 5 years of 1900 to 1920 to 24, 2020 to 24. Every season, this is in Fahrenheit, not Celsius, every season's been warming, and winter especially. And the graph on the bottom is New England, New Hampshire, and we can see that New Hampshire is similar to all of New England. In every single season is warming. Winter especially is warming, and minimum temperatures are warming the absolute fastest. And that's one of the reasons why we don't feel the change as much because those minimum temperatures rising. And also with winter temperatures rising, who does not like a warm day in March, right after the winter? And so we're getting those warmer days, and it almost is pleasant, so we don't notice the change. This is the satellite data. The satellite went up in the year 2000. And again, I averaged them in these 5 year blocks. And again, we can see the last 5 years, an acceleration of the temperature of the land in New England. Here is a map. This is in Fahrenheit. And there were no areas of New England between 2000 and 2025 that cooled. The entire area of New England warmed, and New Hampshire primarily warmed between 2 and 3 degrees Fahrenheit. And then winter, we are warming the fastest. You can see quite a difference between annual and winter. And Maine in particular, especially Maine that's near the water, is warming very fast. But in the wintertime, much of New Hampshire, as well as the rest of New England, is warming. The reason why New England's warming is one, as Reinmar showed at the beginning there, globally we continue to increase the greenhouse gases in our atmosphere, and that is driving the global warming. A rising tide rises all boats, right? The second thing is heat is coming off the Gulf of Maine and Long Island Sound. Both those water bodies are warming very quickly. And so the airflow is moving that heat to the land. And the third thing is we don't have the snow on the ground as much as we used to. And with less reflection, more energy is being absorbed. So we're warming in the wintertime. Here's an image that shows the Gulf of Maine is warming quite rapidly. And that warmth is adding to the warming of New England. I don't know if you noticed that part of Maine that juts out is really warming. And as you can see on this map, it's surrounded by the Gulf of Maine, where you get some of that heating happening. A number of years ago with a graduate student, we looked at snow cover and its relationship with surface temperature. And the main conclusion, looking at northeastern North America, we found a very strong relationship. between decreasing snow cover and increasing land surface temperature. It's clear when there's been a fresh snow, you often wear sunglasses outside because it's so bright because of the reflection off the snow. When there's not snow, most of that energy gets absorbed. Another paper I wrote, I looked at snow cover loss all around the world. And that area in southeastern New Hampshire and much of eastern Massachusetts down to southern Connecticut, those areas in red are the snow covers disappearing faster than 95% of all the other areas on Earth that are losing snow cover. And the pink is the top 10%. So this area actually is a global hotspot of snow cover decline. And again, the data set says, is there snow? Is there not snow? The reason why I'm interested is because of the reflection. So this is a map showing the results of the change in snow cover. How many days is there snow on the ground back in the year 2000, or actually the first 5 years of 2000 through 2004 versus 2021 to 2025. And we can see the red is greater than 40%. I live in an area in Swampscott, just south of Salem, Massachusetts, that has lost over 40%. There's 40% fewer days in the year now that there's snow on the ground than in the year 2000. It's just been 25 years. And even southern New Hampshire has that yellow, which is between 20 to 30% loss of snow cover. We can see it going along coastal Maine. Everywhere in New England has lost some snow cover, a number of days without snow. And sometimes I cannot believe my research. It's like it just doesn't seem possible. And then last Friday, I was driving to Norwich, Vermont, going along Route 89, and there's snow there now for sure. But in the middle of January, no snow here. So we are seeing fewer days with snow cover. Here's the satellite view of New England, and we can see that snow cover is decreasing. And here are each of the states. The scale is the same, 18 points from top to bottom. You can see that Connecticut, Rhode Island, and Massachusetts, the past 10 years, snow cover has really dropped quite a bit, and we saw on that map. New Hampshire, the past 10 years, has seen a decline of snow cover. In the past 5 years, it accelerated. Even Maine, which has been hanging on to its snow cover for a long time, it actually saw the fastest decline in the past 5 years. So it's a pretty broad, what's happening in New Hampshire is happening throughout New England. Okay, here's another graph I want to show you is this graph along the bottom is temperature in degrees Fahrenheit from 0 degrees up to 120 degrees. And the vertical column is how much water can the atmosphere hold. And the warmer the air gets, the more moisture the air can hold. In fact, each of these colored blocks, I increase the temperature 20 degrees Fahrenheit. The red, I go from 0 to 20. The orange, I go from 40 to 60. And the green is from 80 to 100. And notice on the left-hand side, the warmer it gets, not only does the air hold more moisture, but its capacity, its ability to hold moisture increases dramatically. And there is a saying, right? Too cold to snow. And the reason why when it's around 0 degrees Fahrenheit it's too cold to snow is because there's almost no moisture in the air. But when it gets up to 80 to 100 degrees, there can be a tremendous amount of moisture in the air. And we've measured it. One thing we do in science is we're constantly measuring things, and we have measured that in fact there is more moisture in the air because the air is warmer globally. And in New England, we saw that the air has been warming up. And when the air warms, it holds more moisture. And not only that, warm air has more energy in it. And that energy can go into evaporating. And so, one thing we're seeing now, one thing that is predicted also into the future, are more summer and fall droughts. And if you live in northern New Hampshire, you knew that we had a pretty serious drought this year. And each year, as the air warms, it's like you have a vacuum cleaner and you get a bigger bag to hold more dust, and you get a more powerful engine to suck up that dust. And that's what our atmosphere is doing. It's now been labeled atmospheric thirst. There's more room for moisture and there's more energy to evaporate it. Last year, southern New England had more intense drought, and we had a lot of fire down here in southern New England last year. Another thing that happens because the air can hold more moisture is that when it lets that moisture go, often it lets a large amount of water go. And this is for the United States. And it is extreme precipitation events. And you can see that they have increased. And New Hampshire has been hit with some pretty severe flooding. Vermont has especially been hit a number of years with severe flooding due to letting that moisture go and from the atmosphere. I'm not talking so much about rising tides, storms, sea level rise. Mary's going to talk about that. But the moisture in the atmosphere is also adding to that as well. Precipitation changes in New England. Overall, precipitation is increasing. There's heavier rainfalls. As that graph showed, the United States, New England is experiencing the same. And with those heavy rainfalls, there's faster runoff, less infiltration, and there's more erosion. Uh, Rain and precipitation tends to be increasing more in the wintertime than the summertime. In the winter, we're getting a higher rain to snow ratio. So each year we tend to get rain more often than snow. And then we've got this thing called weather whiplash, where climate is changing from, or weather is changing from wet to dry, hot to cold, very quickly. And finally, summers are getting hotter. They're having a similar set of precipitation as in the past, and so there's more of that atmospheric thirst, and so we're seeing more water stress in the summertime and into the fall. And it's not just New England with these heavy rainfalls. This shows much of central United States and the Northeast is having these serious rainfalls. The Southwest is having a drought. All right. Some implications of these changes. Um, my paper goes into this in detail. I'm not going to go into so much detail, but we are experiencing higher temperatures, both day and night. We're having more heat waves, and this is leading to related health, ecological, and economic issues. Sea levels rising. We're having increased coastal storms, which is leading to coastal flooding and erosion. As I mentioned, we're getting those extreme precipitation events. Flooding is happening, getting more droughts and weather whiplash. Impacts the natural world. Ecosystems are the timing of food sources for different animals is changing. In the oceans, we're having migrations occurring, and so fisheries that we relied on in the past may not be fisheries we rely on in the future. The fastest changes actually are going on in the oceans, where most of the energy is being absorbed. Impacts to agriculture. New England is a forested area, and there's some pretty severe impacts on forests with in-migration of pests, with milder winters, in-migration of other plants into the area, economic and social costs, uh, infrastructure resilience to climate change, which I think is something Mary will touch on. Our future. So, We continue to put carbon dioxide in the atmosphere. Not only are we continuing to do that, but the past few years we've actually increased the amount that we're putting into the atmosphere. We're not slowing down. And the graph on the left, at the bottom, is temperature in Antarctica. So not only can we get those air bubbles to tell us the atmosphere, but we can measure the temperature in the past with a thing called the oxygen isotope analysis. The blue line is those carbon dioxide concentrations that we saw at the beginning of the show tonight, and they're related to each other. As carbon dioxide goes up, temperature goes up. As carbon dioxide goes down, temperature goes down. In fact, carbon dioxide has been called the thermostat of our atmosphere. And on the top right, you can see the current area where we are with carbon dioxide, and we are out of the ballpark. Just like earlier, I showed temperature relative to the past 1,500 years that showed we're out of the ballpark. And so the top graph on the left shows that we are continuing to get warmer. And on the right, now we know about the atmosphere's ability to hold moisture and give up moisture. And we know that the future is going to be one of potential drought, floods, etc. The key takeaway is that we no longer live in a climate that's stable. Our new climate that we're now in is characterized by instability. We used to be able to rely on that farm field in Iowa is going to have a certain amount of sunlight and temperature and precipitation, and now that's changing. The instability is not only temperatures rising, but snow cover is declining, and we're experiencing more weather events like floods and droughts. All right. Thank you. And I hope that gave you a sense of what's happening in New England. And Dr. Stampone will talk more about uh, New Hampshire.
Thank you very much, Dr. Young. Awesome introduction to the regional picture. And Dr. Stampone will now pick up and look in more detail at our state. Dr. Stampone, do you want to share your screen?
There we
All right.
go. All right. So are you seeing presentation view or full view?
This is the presentation.
How about now?
There you go.
Perfect.
Awesome.
Full view.
I switched monitors and it switched it all on me. So,
Okay.
okay. So thank you all for being here and for having me tonight. And thank you to Stephen for that very, very interesting presentation there. So again, I'm Dr. Mary Stampone. I'm an associate professor of geography at the University of New Hampshire, where I serve as the New Hampshire state climatologist. And so, unfortunately, I don't have any of the updated materials from the coastal report to share with you since that's not technically published yet, but I would be happy to talk about that during the Q&A. I can certainly do that because just can't share the images yet. But tonight, what I was thinking of doing here is to kind of build off of Stephen's presentation and to kind of take us into that future to look at how climate change may manifest here in New Hampshire over the coming decades, and what the potential impact the decisions we make today regarding emissions could have on the extent of the climate change that we need to adapt to. And so to start off, in a presentation for New Hampshire Network several years ago, my colleague Cameron Wake and I previewed some of the key indicators of 20th century climate change here in New Hampshire from the latest state climate assessment, which was published in 2022. From this report and, of course, other regional reports like the National Climate Assessment, we know that New Hampshire and the greater New England region has become both warmer and wetter, with an increased occurrence of both warm and wet weather extremes. And, and in fact, and I think Stephen mentioned this, the Northeast region is warming faster than most of the US, and the seasonal temperature differences are decreasing, of course, in response to that winter warming rate, which is warming at 3 times faster than summer. And so, kind of going back to the results of our own state climate assessment, in that report indicated that, of course, here in New Hampshire, our temperatures have already increased about 3 degrees Fahrenheit since the beginning of the 20th century when records began. And the energy then retained by additional greenhouse gases in the atmosphere have led to an increase in total annual precipitation of about 8 inches. And this is largely due to an increase in the frequency and intensity of extreme events. And of course, Stephen talked a little bit about why there is that connection between warming and more water in the atmosphere. And so, we are already being impacted by, there we go. We're already being impacted by these increases in temperature, as well as heavy precipitation and runoff. And of course, these trends are expected to continue through the end of this century. And so I want to take a minute here to kind of go through this graph and explain how we look at projections and how we estimate what types of climate changes we can expect and that we'll have to deal with in the future. And so generally we do expect that the state and the region and the world will continue to warm beyond 2040. But the rate and the magnitude of that change still depends on greenhouse gas emissions now and the resulting accumulated atmospheric greenhouse gas concentrations over the coming decades. Right, so to assess these potential changes in regional climate in response to emissions, we project the future climate conditions for different socioeconomic scenarios, or what we can call pathways to warming, that simulate human activities that can lead to more or less global warming. And so that's what we're looking at here. And so in this graph, this is from the state climate assessment, showing, just as an example, the change in annual maximum temperatures. So these are average daytime temperatures. And so the dark black line, those are observations from the US climate or historical climate network that Stephen mentioned. And then over on top of that are projections from a suite of climate models. And so all of the thin lines represent all of the different climate models. You can't just take the output from one model, right? There's not just one option here. We need to do multiple model runs to kind of get an kind of an array of potential outcomes. And then we take the average of them as what we use to say this is how much we're going to warm, or this is how much wetter things are going to be. And so displayed here in gray are the portion of the model run that overlaps with historical observations. We usually kind of start things early so that we can see how the model aligns with what we've already experienced. So if the model agrees with what has already happened, we have more confidence in what the model's projecting for the future. And in this case, the renewable energy efficient pathway. So this is more along the lines of kind of what the world committed to doing at the last or at the 2015. This is not the last one. The 2015 Paris Climate Agreement. We obviously haven't met those emission caps. But this is kind of assuming we stay along the lines of what we've already committed to. And so this does assume that there are regulations on greenhouse gas emissions, and we lead to more energy efficient renewable energy sources. And so the blue line represents this, and this is a future then with substantial greenhouse gas mitigation that leads to a stabilization of atmospheric greenhouse gas concentrations, limiting warming for the latter part of this century. So we still are going to warm, but we're going to limit the amount of warming we experience by the end of the century. And of course, by comparison, all right, so by comparison, The red line, that should show up here in a moment, shows what we call the worst case scenario of unregulated greenhouse gas emissions. Back in the day, this used to be called the business as usual scenario. And this results in accelerated warming, especially after mid-century. And so you can see in this graph that the two scenarios kind of line up for the next couple of decades. But if we reduce our emissions now, we can really see the difference for the end of the century, where we see the accelerated warming occurring under the higher emissions scenario compared to the lower emissions scenario. And so again, by comparing these different model simulations of the climate system response to human activity, we can clearly see the stabilizing impact of greenhouse gas reductions have on the warming rate beyond 2050. We're all kind of already locked into a certain amount of warming, but we can still limit the amount of warming we have at the end of the century. But I guess, the question for a lot of people is, so why? Why do we need to do this? Why does this actually matter? And as Stephen explained earlier, temperature and precipitation trends are closely linked in Earth's climate system through the water cycle, where warming increases the evaporative capacity of the atmosphere, resulting in an increase in the frequency of heavy precipitation events, while also increasing the potential for the development of rapid onset droughts during the warm season, just like the one that developed in August here. Even though it was wet, above average precipitation in June and July, we still ended up drying out in August in response to warming. And as in the past too, continued warming in winter will result in overall milder conditions. And this is associated with less snowfall and decreased snow and ice cover. And so kind of going back to the graph I just showed, keep in mind that with every degree of additional warming, that combination of increases in temperature, heavy precipitation, reduced snow and ice cover will result in even greater changes to our environment over the coming decades. And this is going to make adaptation challenging, especially rapid adaptation, and further risk the health of New Hampshire's residents, ecosystems, and the industries they support. Therefore, the amount of change we will have to adapt to will be less for a lower emissions, renewable energy efficient future. So to kind of illustrate that, I want to go through a couple of model scenarios for some extreme weather that we're very concerned about here in New England. And we'll take a look at the two different scenarios. And since we just heard about snow, I thought we would start then with precipitation. Right, so overall we expect more precipitation annually. But the projected increases in total annual precipitation will not be evenly distributed throughout the year. And they are projected to shift to more precipitation during the winter and spring seasons, with little change expected during summer and fall. So using the regional climate model projections from the National Oceanic and Atmospheric Administration, or NOAA, we can get a sense of what precipitation patterns will be like through the end of this century under lower emissions compared to what we could see under the higher emission worst case scenario, which is going to lead to maximum global warming. So here we're looking at projections for winter and summer precipitation by 2050 as a difference from historical. We fast forward to 2090, under lower emissions, we can see a greater increase in precipitation during the winter with little change projected for summer. Now, if we move to the higher emissions, so assuming we don't regulate greenhouse gas emissions, we see the seasonal difference in precipitation becomes much more pronounced. So we have much more precipitation happening in the winter. Again, very little change in summer. And so just as in the past, the increases in winter season and total annual precipitation shown here for 2050 will largely be due to greater frequency and intensity of extreme precipitation events. right? So now I'm going to show you some data from the climate assessment, right? So for select New Hampshire cities, the state climate assessment included local scale or downscaled projections of extreme precipitation, which we defined as 1 inch or more of rain or liquid water equivalent snowfall occurring in 24 hours. So plotting these data on the map, we can see that precipitation events greater than 1 inch are expected to occur more frequently across northern and interior parts of the state over the coming decades. So this is by 2050. Meanwhile, the seacoast may see a near doubling of precipitation events greater than 4 inches by mid-century. So these are your bigger, your nor'easter type events, right? And again, these storms for coastal areas, right, are more likely to occur during the cold season. That's where we're seeing more of the precipitation increases happening. So these are occurring during the cold season, which increases the risk for storm surge flooding along the coast, as well as flooding associated with rain on snow inland. However, for southern parts of the states, the warming will reduce our snowpack to the point where we're actually going to have less of an increase or less of a risk for rain on snow events. That's one of the things we cover in the coastal report. Okay. So now, right, with more precipitation projected for winter and spring, the question is, how much will fall as snow versus rain, right? So winter, already the fastest warming season across New England. And as average winter temperatures warm, that frequency of below freezing temperatures will decrease, resulting in overall shorter and milder cold season. So once again, I want to look at some of the local scale projections from the state climate assessment. And we can already see by 2050 that there is a substantial reduction in the number of days below freezing by 2050 compared to the 20th century occurrence. So the number of days that drop below, or days with daytime highs that are still below freezing, historically are in the black. The change by 2050 is in the blue. And we can see that there is, again, substantial decrease in the number of those occurrences. And so this is important because even for the nights that still drop below freezing, right? So it can get above freezing during the day, but still get below freezing at night. But the more this happens, we'll see more intra-seasonal thaw events. And we're already seeing this, where we have a snowfall and then it melts. And then, we might get snow overnight, ice in the morning commute, rain during the day. And this could lead to an estimated 20 to 50% decrease in the proportion of cold season precipitation falling as snow compared to now. But beyond 2050, lowering emissions to limit warming results in little change in the number of below freezing days by the end of the century compared to projections for freezing daytime temperatures under the higher emissions. And so this combination of projected warming with the increases in total seasonal and extreme precipitation increases the risk for late winter and early spring flooding in terms of both the magnitude and the frequency. But reducing greenhouse gas emissions over the next few decades will likely reduce the impact of global warming during that cold season, resulting in substantially colder winters with more below freezing temperatures by the end of the century than we will see without significant mitigation. Now, finally, let's turn to the summer season for a bit here. So here again, the warmest daily temperatures will increase. And at a minimum, we can expect a doubling of the number of days above 90 Fahrenheit by 2050. We're already well on our way there. This, of course, increases the risks for more prolonged heat waves and the resulting drier soils from warmer temperatures, fewer light rain events, and longer periods between heavy rain events sets the stage for more of these rapid onset summer droughts, even as we get wetter. And every summer for the past several years, we have at some point ended up in a drought situation largely due in response to just the heat pulling that water out of the soil and drying things out. But again, just like in winter, right, the summer season warming rate stabilizes after 2050 under lower emissions, which limits the projected change in summer daytime temperature to approximately 5 degrees Fahrenheit by the end of the century. So we're still going to get warmer, but a lot less warmer than we will without mitigation, right? So the highest summer temperatures could increase by as much as 12 degrees Fahrenheit during the summer months under the higher emissions scenario. And the number of days above 90 Fahrenheit could occur twice as frequently under high emissions than they are expected to occur under the lower emissions scenario by the end of the century. So again, reducing emissions and following the lower emissions scenario saves us a lot of change to which we need to adapt. Right, so speaking of that, the changes, right, have and will continue to impact our state's economy, as well as the health of our ecosystems and the health of residents. And we can't eliminate the risk posed by climate change entirely. Again, we've already committed to a certain amount of warming based on past emissions, and things will continue to change. But we can reduce them over the next several decades by building resilience to climate-related hazards through the combination of adaptation and mitigation, right? So adaptation, as the measures taken to manage or reduce the risks of climate change, include things that the state is already doing and the region is already doing. So things like hazard planning, as well as infrastructure projects that are absolutely essential for building adaptive capacity. Things like increasing the size of culverts for rainwater runoff, things like that. Those are all things that we're doing and that we need to continue to do. And again, while adaptation activities, again, are absolutely necessary, such actions are limited by the capacity of the system to respond to change. And that capacity to adapt will be lower for greater rates of warming. All right, we're just going to have a tougher time adapting to change the greater the change is. And so mitigation, which through emission reductions directly addresses the cause of climate change. It increases the efficacy of adaptation, which makes it an essential adaptation action in and of itself. And so we can think of adaptation and mitigation as complementary strategies for reducing and managing the risks of climate change that, together with education, planning, and policies that protect and conserve natural resources, all build resilience that allows us to anticipate, prepare for, and respond to climate-related hazards in the future. And if we don't, the state's weather-dependent industries will be impacted. They already are, and they will continue to be impacted by, the increase in heavy precipitation events, especially during winter, which will likely be shorter and milder with less snow. And then during the summer, the threat posed by extreme heat could increase drought risk because, again, unlike winter, projected summer warming does not coincide with potential increases in rainfall. All right, so we still have some choices to make, and we'll leave it there and be happy to answer any questions you might have. Thank you. See lots in the chat.
Thank you very much, Dr. Stampone, and Dr. Young as well. Yeah, we have quite a few questions, and I'm going to get to them. I want to ask each of you one question, which comes up a lot to us. And so I'll just put it very, very crudely. First, Mary, you're talking about future impacts on New Hampshire. You're talking about adaptation and mitigation. New Hampshire has relatively little industry, right? So it's not really our fault anyway. Why should we change our habits? We're a small state. We're not contributing to this problem very much. What can we do and why should we do it?
Well, this is a global problem, So everyone needs to contribute, those who are contributing to warming more. And we can argue that, US as a whole historically has contributed far more emissions to causing this problem than some of the newer emerging economies have in the decades where they've been contributing. So it's not just who's contributing now; it's what we've already put up in there, and we have emitted our fair share. And this is one world. We're all in this together. We all have to do it because we are going to be impacted by it. You can't just have, one place do what they need to do and then the other place isn't. It just doesn't work that way. And our industries are vulnerable. We have a very vibrant tourism industry. Some of our biggest money makers are weather and climate dependent, and so we're dependent on this. And so we need to be part of the solution.
Thank you very much. That's a question that comes up a lot. That's why I'm asking it.
I hear it
Um,
all the time, and I'm like, we're in this
yes,
together,
of
man.
course.
I mean, it's everyone.
Stephen, question about the climate. You mentioned as part of your conclusions that we're going to be in an unstable situation, climate-wise. Our climate is going to become less stable. But everyone has always complained about the climate being unstable, especially in New England. Everybody says, wait 5 minutes and it'll change if you don't like the current weather. Um, so is it a situation where it's like you haven't seen anything yet? Or what is the situation? Because it's supposedly been unstable before, and you're saying it's going to be more unstable.
So the thing about wait 5 minutes and it'll change. Yes, weather does change, and that's why those dots that I pointed yearly go up and down. The difference is that in the past, we would always return to a normal, an average, and that average wouldn't vary very much at all. That's not happening anymore. We're not returning to a long-term average. We're returning to a point of increasing temperatures, and that's going to continue. So that's the difference. Yeah, and one problem is humans have a very short memory. And so we remember a couple of years ago, and now it seems colder than it was a few years ago. We don't have the remembrance of 30 or 40 years ago, where data observations, the data that I use, can show the change that's happened. But humans, we don't have that long term memory, so we don't see that whiplash that we're on that warming trend, and it's not just going to come back to a same average. Does that make sense?
Yes, thank you. Great. John and Susan, do you want to mention some of the chat questions?
Well, a number of people have been asking, what can we do? One really easy one, if you're in a community that has community power, opt up. You can, yes, you save a few more pennies if you don't, but if you opt up, pay that little extra to get all your energy from renewable, that's less carbon production. But I'm wondering if Mary or Stephen would have other comments about ways that we as individuals, and I know people are talking about political solutions too, but just as individuals, what should we be doing?
So, right, the one thing is, as an individual, we're not gonna save the world, and we're not gonna do it all. What we need to do is find out what your expertise, what your passion is. Mine is education. And so I teach climate change classes at the college level. I give public lectures about the science of climate change. And so I pour my energies into education. Other people who are more politically savvy may pour their time into choosing candidates and working to help those candidates. People that are in finance may use their expertise to help support the investments in clean energy versus fossil fuels. So my advice is you find your passion, your area, and do what you can in that area, if that makes sense.
Definitely. Dr. Stampone, do you have a response to that particular question about individual contributions?
Yeah, and it, and Stephen's absolutely right. It's, one person isn't going to change all of this. But there's a lot of psychology on this that I've started to get into because I teach undergraduate students who are quite upset about this to the point where they, why should I even bother? And no one else is doing anything. My future's already, you know, written in global sea level rise. So, what can I possibly do? And giving up is the worst thing to do. And and I think of it. There's a bit of hope you can get from trying to do something. So if you can, as an individual person, do what you think you can do and what feels right for you to do to be addressing this problem. Um, and it spreads. If your neighbor sees you put up a solar panel, they, oh, how much did that cost? How about you again? Oh, maybe I'll look into it. Give them the card of the person who installed it. And these things can spread through your communities. You have time, get involved at the town level. Towns in New Hampshire are really doing a lot of fantastic work in the, not just the adaptation, but the building of the resilience, which a lot of those resilience efforts are also good for mitigation. And so, there are lots of ways you can be involved. Don't put the pressure on yourself to be perfect or change everything, but just keep working at it. Is kind of my advice of what people should be doing.
Right. John, did you I see you've come off mute. Is there a
I w
question you want to ask?
I was going to follow up with that same question. Richard Kahn, is talking about his personal efforts. He converted his truck to burning vegetable oil, and he's just wondering, does that make a difference? And I think you answered that pretty well. It's good to do for personal reasons, but it's not going to save us from hitting the maximum temperature that we're headed for. We need policy changes to make the big economy-wide global changes that will do the big lifting.
There's
Um,
one other way of thinking about that, I think, which is possibly useful, which is that if we do things like making the truck run on vegetable oil, we've 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 made ourselves independent of a system that's not very functional. And that independence is actually a good thing psychologically and also for people to observe and to learn from. So, so it's, the more people can become independent of the system that's heading us in one direction that we don't really want to go in, the better we're off. So there's something that it's not just psychological, but it's partly psychological, what we do as individuals. Great. So
Can I
if
just
it,
follow up real quick on kind
yes,
of the bigger
please.
scale too? So there's a lot of work saying that, like economically speaking, we're going to move in that direction because renewable energy, over time is going to be cheaper. Um, but kind of on the being involved in trying to move policy along, I don't think we have the time to wait for the economy to do the right thing. I think we need these policies sooner than that. So.
Yeah, I guess to follow up with that, Dr. Stimpone, would you say that everybody's best efforts now, and with clean energy getting cheaper and that's going to get used more, is that the path to the high emissions future that we're looking at? Like with all of the good things that are happening now, are we on a path that shows that we need policy changes to get on a low emissions path?
Yeah, we not on the worst case scenario, not yet. We're not on the best one either. We're somewhere in between. And so the path we're on now, I mean, we're surpassing 1.5. So the Paris Agreement and everything there, we're beyond that. The goal now is to try to keep it to 2 degrees Celsius of warming because that's kind of the point where historically, you know, we haven't exceeded that in sort of modern human history. And so, how society can adapt to those changes is a big question. Um, And that's why that 2 degrees Celsius is kind of that point of no return. We're about maybe a little bit above that is where we're aiming for right now, given what we're doing. Um, and we do need to do better. But again, so far, we're not on that worst case scenario yet. We're somewhere in between.
Somebody asked a question related to that, which was, do we need to adjust the models if the models are, if we're actually on a slightly better trajectory than the models have been showing? Do the models need to be adjusted?
So these are multiple different scenarios. We run them all. I showed 2 of them. I showed the one that's more like the path we're on, which was the efficient future, and then the worst case scenario is kind of the upper limit of we do not want to hit. There are several scenarios in between that model different types of geopolitical and socioeconomic structures that could happen in the future, that give a sense. So the IPCC report provides more on what those look like. And we consider those as we kind of downscale. And just as a little preview of what is coming out in the coastal report, we did use the newer models. And what those models are showing is that we're getting even wetter in the winter. So some of these precipitation extremes are likely to be even more extreme going forward. So again, these are there's a bunch of different ways in which we can approximate that. I'll come up with different answers that we can try to model our behavior after, depending on the outcome we want.
Hello,
Mm-hmm.
can I speak?
David Kunhardt from Tamworth has his hand up.
Thank you very much. Thank you very much for these presentations. It's very illuminating to see your hard work putting this together. I just wanted to cast a broader net, and I'm glad, Mary, that you just mentioned the IPCC, because the International Panel on Climate Change, the scientific community, has been saying for probably 10 years that we need to put a price on carbon, that's going to be a very effective tool. The economists in the world have reached a tremendous consensus of opinion about pricing carbon as being a very efficient and effective tool. They have also, from the IPCC, for about 5 years, been emphasizing something that, in fact, a number of Republicans are favorable to, and that is scaling up greenhouse gas removals. It's not just a matter of dipping down the level of emissions, or adapting and building more walls to bigger waves, but to draw that down. And our work in forests helps a little bit. Certainly, our work in a number of other areas, and now there are over 700 new companies in the world that are working on greenhouse gas removal. This was featured at the COP30, that is the Conference of Parties in Belém,
Sorry, David.
Brazil.
David, do you have a question?
I wanted to get Mary's reaction to the notion that we should start scaling up greenhouse gas removal as we also scale down emissions, because it's the legacy greenhouse gas that's causing the problem of temperature rise.
I mean, all options should be on the table. I mean, this is not, this is going to be a multifaceted approach, and we can't just be relying on one source of energy for everything anymore. We have the technologies to reduce emissions, without relying on the carbon capture. And my concern with efforts going into carbon capture alone will be used to just offset continuing to emit, where we need to reduce the emissions, and then kind of use the carbon capture to account for what we've already put in. But again, the emphasis really does need to be on emissions, and we again have the technology to do it. We just need the policy.
Speaking of which, we've got Dan Weeks with his hand up, and I'm sure he has something to say about the technologies.
Thank you so much. I really appreciate this presentation. Apologies for some kids in the background here. I just wanted to briefly comment on the lens through which we talk about solutions. I imagine for a lot of people gathered here tonight, there is a sense of sobriety around the scope of the problem and the imperative to act. And I know many people here have been first movers adopting clean energy in your personal lives when it was certainly more expensive and required sacrifice. I think we're at a point today as we try to reach a much wider audience of adopters of the solutions, as well as advocating for the policy changes, where we can honestly speak about just the material benefits, the comfort of living in a home heated and cooled by heat pumps, electric, efficient heating and cooling, of the money savings of generating your own power, with solar now being at scale well below the cost of traditional fossil fuel generation and representing over 90% of new power generation added to the grid, solar and wind, as well as the convenience and tremendous cost savings of driving electric. And others are aware of these solutions. But I think we've passed a point over the last couple of years where we can speak to those people who don't necessarily come to this with any awareness of or concern about the climate. But all of us are concerned with living comfortable and affordable lives, affordability being the issue du jour. So I just want to encourage that as we talk about the solutions, we really emphasize the tremendous quality of life benefits that they do offer increasingly today, first and foremost in terms of cost savings, and thereby hopefully appeal to a much wider audience. Thank you.
Thank you, Dan. And to add to that, New Hampshire Network is partnering with other groups in New Hampshire and more broadly to simplify solar, make it easier and cheaper to put solar on your rooftop. And also, we're going to be working on wind power as well. So these are things that can be pushed forward much faster than they have been, and time is of the essence. We don't have a lot of time just to kind of argue about things at this point.
I guess
Walter Payne
before we
has
get
his
to
hand up.
Walter, I'd just like to add, sorry,
Yeah.
Reinmar. Yeah, Representative Corman was commented earlier about, or sorry, maybe it was Kaplan, Representative Kaplan, that showing up at the Concord State House to testify does have an impact. But I was at Bill yesterday, HB 1542, and it was a disaster. There was, I think, 88 people testified online against the bill and 3 for it. About 8 people testified against it in person and one for it. But the committee seemed to have made up its mind, the majority, before even the testimony had happened. I think it's going to take a lot more people than 6 or 8 showing up to get, especially the Science, Technology, and Energy Committee of the House, to start changing its direction. And its direction has not been good at all for incentivizing clean energy, energy efficiency. And the bill we heard yesterday was to get rid of basically the renewable portfolio standard and the RECs that the energy providers have to buy if they don't meet minimum clean energy standards of the percent of energy that's delivered to all of us on the grid. They're whittling away at even what we have, let alone not doing more that's needed. And I think it's going to take people going and talking to them. And one of the things that we've been trying to do with the network and CCL is encourage people to contact their own state representatives and try to get them to put some pressure on Representative Vos, the chairman of the committee, to invite our state climatologist in to help answer their basic climate science questions, because what they say in committee hearings disturbs me deeply, and I'm not a climate scientist, but I've read things from NASA and NOAA, and they just don't understand the basic science or trust it, or think the government needs to get involved, and we can all help put pressure on them to take it more seriously.
I agree. Anyone of us who has enjoyed and learned from this webinar should put pressure on that committee to do the same, to learn and to enjoy what Dr. Stampone can bring. Now to
Reinmar, can
Walter
I?
Payne.
Oh,
Oh,
can I
sorry.
intrude for a minute, Reinmar? This is
Yeah.
this is the real Susan. There are many clones out there.
Okay.
But I think it was Sue Vlatnik or a couple other people were asking, is there a way that we can talk to people in our own communities that, because what a community does can make a big difference. More EV charging stations or solar for municipal power, LED lights. So what are ways that people can talk to their very own community leaders where you have a better chance of being heard? Any thoughts about that? And a number of people have pointed out that uh, a number of websites are being scrubbed and unavailable, and maybe a comment on how you can still get hold of climate records that you're looking for.
Susan, who was your question addressed to?
So a couple people mentioned I can't get hold of this climate information or that climate information because a certain administration has taken them off the website. So is
Mhm.
there some way still to get climate information? That was question one. Question two, what are ways to talk to your own community, your select board, your about climate changes that can happen, adaptations, mitigations that can happen in your community? Mary, you indicated that's important, but it sounded like this person maybe needed specifics, or maybe it's the job of New Hampshire Network to come up with presentations that people can do in their communities. Uh,
And community, not necessarily your local area, but could be your church community. And you can talk with fellow parishioners about getting solar energy for the church, or having native species or pollinator gardens at the church. So there's many different communities. And I think it's very important to talk to as many communities as possible. You don't have to have a PhD about climate change to have some understanding and be able to talk with others about it and about bringing about change. So I'm all for talking with your different communities.
Yeah, and real quick, I did put a link to NOAA's archive where they have posted, it's a huge PDF, but it's there. They've archived the last National Climate Assessment, which was taken offline. If anybody has any trouble finding government documents, feel free to email me. I have a lot of stuff saved, so I'm happy to distribute anything that anyone's looking for if I have it. Also, for the community, in my experience here in New Hampshire, go to your town's planning board meetings and make a fuss.
Okay, and Sandy Crystal
Great.
says make sure your town adds a climate chapter in its master plan. And we'll be sending out the chat and your email.
Yeah. I want to move quickly to some more questions because I have to leave a few minutes at the very end for Susan to talk about coming attractions. Let's go to Walter Payne.
Thanks a lot. Sorry, I can't figure out how to turn on my camera on my phone. I'm usually on a computer. So these are more comments. Earlier, someone mentioned the argument. I think he was just presenting it as not a good argument, but an argument that people in New Hampshire are not responsible for climate change since we have very little heavy industry. But of course, I don't know about you. I heat my home with natural gas. I drive a gas car. I occasionally get on a plane. And when I buy a manufactured product, even if it's not produced in New Hampshire, CO2 is emitted in that production, and therefore it kind of counts on my tally. However, I'm not endorsing the shaming strategy. Of course, what we need are incentives to use less CO2 in everything, and obviously, as people have mentioned, carbon fee dividend is the best way to do that. Regarding the argument that green energy is now cheaper than fossil fuels, and therefore we just have to wait for the process to occur. There's a couple of big caveats there. Number one, if you already have a house, particularly if it's like 100 years old, and it has a fossil fuel heating system with radiators all over the house, and maybe you don't have air ducts at all, to install a heat pump is incredibly expensive. Likewise, if you already have a gas car that's got another 6 years in it, to go buy a electric car is a lot of money. And then also there are a lot of technologies where there is no alternative green technology that is remotely competitive on price. That would include, of course, air travel, making concrete, making steel. And again, the same way to incentivize the rapid conversion to the technologies that exist and to develop new technologies for the things that don't exist. This is, of course, by pricing carbon. And then finally, I think that it would be great if, this is a great presentation, by the way. I hope it's taped so I can show it to some other people who live in other parts of New England. I think it would be helpful at this point if scientists who talk about climate science would at least mention, without perhaps an endorsement, that the scientific consensus on how to reduce CO2 emissions is just about as strong as it is on the scientific consensus of the cause and risks of climate change. And it's probably past time for them to be talking about just go talk to your neighbors and stuff like that, which is wonderful. But at the end of the day, we need policy changes, and pricing carbon is the single most effective one. So,
All right.
yeah.
Good, Walter. Thank you very much.
Thank you.
We've got Ken Selene also.
Yeah, great presentation. Really appreciate it. My question has to do with jobs related to renewable energy because when you talk to the general public, to be honest, the other issues like taxation, schools, they resonate with the public, maybe with a bit more importance. But if you start to approach them in the terms of jobs, because the jobs created by renewable energy are good jobs. They're New Hampshire jobs. And if you think about it with solar, you're harvesting the energy in New Hampshire. The systems are being built and integrated by New Hampshire labor. So it keeps that money in the New Hampshire economy. So one of the things I'd like to see is, maybe a report on the impact of that side of it, what jobs is renewable energy or has the potential to create. And I think that would, resonate very well with the legislators as well as the public.
Great. Thank you. Thank you, Ken. We've got one more question from Caitlin.
All right, I'm actually jumping in on my wife's phone because I don't have the raise hand option.
Oh.
So this is Dave Hawk. So I put this in the chat. I don't know if this is the best venue. I'm looking for a career change. So I feel like the last comment and question do a great job of aligning with a question I have, which is for somebody with an engineering background, do you have any recommendations for what is a local sought after position to take? My eyes kind of go in the legal direction. Is that a good direction to go locally, regionally, to start to shift my aspirations towards supporting things that are positive climate oriented in some direction, but doing it on the law sector, which would be a big shift? What are your recommendations?
I'll respond to that. If you have an engineering background and you're interested in the problem of climate change, you're the person that society is looking for. So the more of you, the better. And there's lots and lots of ways that you could go. Could hardly go wrong, actually. Anybody else have any responses to that?
Agreed.
Excellent. Well, we've solved that.
I guess my problem is where to start, and I'm happy to. I know we're coming up on time here, but I'm happy to throw my personal phone number in the chat, and if anybody is willing to bite, follow up and book an hour with you.
Stay in touch, Dave.
Week
New Hampshire Network is set up to accommodate people from all walks of life. So stay in touch. Give us an email.
I'd throw
Okay.
the engineering of batteries, heat pumps, motors.
Yeah.
There's a lot of technology innovation that's still required, and we need
And
all of that.
we desperately need navigators to help us figure out how to make the big changes we're making in our home. It's a hard, hard slog, but it's fun. I have
Elec
to.
yeah. Electricians and energy efficiency work, all our homes and buildings are going to need a lot of work to reduce the amount of energy we're using over time.
Yeah.
Yeah.
The
A lot of it
Monadnock
depends.
region has a program called Energy Coaches where they actually come and help you in your home. So hopefully other regions will figure out how to duplicate that program and make it available to more people. Clean Energy New Hampshire has energy circuit riders that do come help communities. So that's another answer to the person that was saying, what can I do in my community?
Oh,
Maybe just,
thank you.
yeah,
Yes.
get Clean Energy New Hampshire to come and give you a hand, give you some insights. And
Good. And
Reinmar, I want
as
my
long as
turn.
Susan
Yeah.
has as long as Susan has the floor here, I think we should ask her to go through the coming attractions so that we don't go over too much in time.
And I just want to
And she
give
is sharing her screen.
Dan Weeks Revision Energy a plug also. He's here. He didn't say anything, but he's got one of the best
No, he
clean
did.
energy
He did. He
producing
made an excellent
companies.
comment.
Yeah. No, but just want to encourage people to look at Revision Energy for their own personal clean energy solutions for their home. They're very good.
And job
Yes.
opportunities.
Yeah.
Okay, so here we go. And oops. Oh no. Okay.
Next one down.
So this event was sponsored by New Hampshire Network, and we are eager to share what we do. We're just a few volunteers that are making most of it happen, and then we are a community. Most of us seem to even know each other's names. Uh, every week, Bruce Burke puts together weekly updates that tell you what events are happening. Some of them now by Zoom could be happening far away, and some are New Hampshire related, but things to do with energy, climate, and environment. So go online and look up weekly updates on our New Hampshire network. And then what can you do? We've talked about legislation. Every week we update our legislative spreadsheet, which you can arrive at through newhampshirenetwork.org. And I'm not going to go through a whole tutorial now, but on that same web page is an explanation of how you can go to the New Hampshire State House online and vote. John mentioned how many people opposed or supported online. You can vote, I oppose or I support this bill. And we're fine. It's the Science, Technology, and Energy Committee is perhaps not as responsive to what people do online, but some of the other committees really do take it seriously, and we'll keep working on the others that don't. So here's a way always to find out what we recommend, and our recommendations are coming from other major environmental groups in New Hampshire. Okay. Here are our working groups. Oops, Pierre, I hear you talking. Thanks. We've got working groups. You can come join us. At the moment, they're all happening just once a month. But the Municipal Energy Committee is actually helping municipalities come up with better plans and people sharing ideas. Plastics, this Sunday, we're working on a way to try and get fewer plastic bags out by sharing a toolkit of ways that you can do work in your community. So we hope 6 o'clock this Sunday, you might come and join us to find out what you can do to diminish plastic in your community. And then finally, John Gage runs the climate working group, and that meets again February 3rd. So come try it out and become a member of a similarly interested community. This is the advert for what's happening this Sunday. No plastic pollution, no plastic bags, please. And to make it easy for you to remember the Zoom, it's bit.ly/no plastic bags, please, with no spaces. And final advert, please try us out. Come join us, newhampshirenetwork.org. Information on funding, recordings of past events, working groups, legislation tracking sheet, and a statewide calendar. And thank you everyone for being here. And thank you, Dr. Young and Dr. Stampone, for being so illuminating. And Reinmar, back to you.
Yes, thank you very much, Dr. Mary Stampone and Dr. Stephen Young, for your contributions. Thank you to everybody who's been here and listened and been interested. Stay in touch with us, and we have every month. As Susan mentioned, we have virtually every month we have an event of this sort, and we would love to see you all again. And with that, we'll close for tonight. Thank you so much.
Thank you.
Really
Thank you,
appreciate it.
everybody.